Hello friends, welcome to the session on software construction essentials. In this session we will be discussing about number systems. Friends, as you know that in our real life we are always playing with the numbers. Whenever you take admission in a class, then the class is being represented by some number. You will find that whenever you write some examination, then your performance in the examination is being evaluated in the form of numbers. Whenever you want to go from one city to another city by some train or by some bus, then you will find that every bus is having some number. Every train is being identified by some number. So numbers are there everywhere. Whenever you earn any money, then you will find that your earning is also calculated in the form of numbers. So in real life, you will find that numbers are there everywhere. In computers also, the computers that we are making the use of are all digital computers. And in the digital computer, everything is being represented in the form of numbers. Say for example, when I have some voice or when I have some video or when I have some data with me, when I have some picture, then you will find that everything whenever we store into the memory of our digital computer system, then that is being stored in the form of a number only. So in this session, we will understand what kind of different number systems are there and in what way it is possible to represent the number in the different number systems. So friends, as you know that I am recording this session for PSS Central Institute of Vocational Education, and these sessions are recorded for the course Junior Software Developer. But the students from other courses can also make an access to these sessions in order to learn the computer science. So let us start the session and let us understand what we mean by number systems. So friends, as we know that whenever we deal with the different real life situations, then in most of the real life, what we have been dealing is with the numbers. Say for example, we are making the use of mobile phones and every mobile phone is being identified by some number. Whenever you go to the lodge or hotel, then you will find that every room has certain number. Your address is consisting of numbers only. Your city has a pin code which is also consisting of numbers. Whenever you read any book, then the pages in the book are being identified by the numbers. There are numbers to the bus, the currency is being counted in the numbers. Whenever we play some cards, then cards also has numbers. Whenever we deal with the calendar, then the dates are having numbers. Whenever we watch, whenever we have watch and whenever we observe our time, then the time is also calculated in the form of numbers. So numbers are there everywhere. So what is this? What are these numbers? Number are there and they are part of a system, and this system is being called as a number system. So number system is basically a collection of symbols, you can say, and there are certain rules that are associated in order to perform certain arithmetic or other operations on these values, and they are being called as a number system. So number system is basically a collection of symbols, and these symbols are being called as the numbers. So every symbol will represent a specific number, and as I said, numbers can be positive, numbers can be negative, numbers can be whole numbers, numbers can be fractional numbers as well. So we can have a variety of numbers, and all number systems will make us allow the different types of numbers. Also, whenever we consider any number system, then you will find that there is no restriction on how many numbers we can write in the number system. You will find that we can write almost infinity number system in any number system. So there is no limit on writing the numbers in the number system. Number systems are very useful, and we can perform the various operations such as arithmetic operations, addition, subtraction, multiplication, division on these numbers. You will find that whenever we think of any number system, then every number system has a base, and that is being called as the basic numbers of the number system. So say for example, the basic numbers of the decimal number system are 10. It means that there are 10 basic numbers, and therefore the base of the decimal number system is 10. Also, it depends upon the digit. The value of any number will depend upon the digit and its place, its position. So where actually we are making the use of that digit, you will find that depending upon the position and depending upon the base of the number system, every digit will have a different value at the different position. And as far as number systems are concerned, you will find that there are 4 types of number system that can be commonly used. One is the decimal, another is the binary, third is the octal, and the fourth one is the hexadecimal number system. So these are the 4 number systems. Decimal is used by us in our day-to-day life. Binary, we use it with computer system. Octal and hexadecimal number system also we use in electronics or computer system whenever we write some programs. So let us understand one by one. Say for example, we will start with our regular number system that we normally follow in our real life, and that is being called as a decimal number system. So deci, it will stand for 10. So this number system has a base of 10. So there are 10 basic numbers, and these basic numbers are from 0 to 9. And after 9, you will find that we make the combination of first 2 numbers 0 and 1, and then we will write this number 10. And then we will write 11, then we will write 12, and in this way we can write the infinite numbers in the decimal number system. In the decimal number system, we can have the numbers which can be positive numbers, which can be negative numbers, which can be whole numbers, and there can be fractional numbers as well. So variety of numbers can be written. Whenever we have some positive numbers, then we can write a plus sign before to the number, or many times we do not write any sign before the number, then those numbers are treated as the positive numbers. And whenever we have a negative number, then we make the use of negative sign, minus sign, in order to indicate that the value of this number is negative. And also you will find that whenever we have a fractional number, then we can make the use of a fractional point, a decimal point, and that decimal point will indicate that this number is a fractional number. Also, you will find that in decimal number system, every digit that we write will have a certain weight, and this weight is in the powers of 10, because 10 is the base of this decimal number system. Say for example, when I write a number something like this 12.67, then you will find this 2 will have a weight of 10 raised to power 0. 10 raised to power 0 is just nothing but 1. And this 1 has a weight of 10 to the power 1, it means that it will have a weight 10. This 6 after the decimal point will have a weight 10 to the power minus 1, that is 1 by 10. And this 7 will have a weight 10 to the power minus 2, means 1 by 100. So you will find that when we go from the point to the left hand side, the weight goes on increasing, and when you go from the decimal point to the right hand side, then the weight goes on decreasing. So whenever we write the number such as 25.386, then you will find that in order to indicate that this is a decimal number, what I do is that I write a base 10. So it indicates that this is a decimal number. Also, I can write a negative number such as minus 67.12. I can write the whole number such as 778. I can write a fractional number with the fractional point also. So variety of ways are there by which you can write the decimal number. And as I said, this is the number system that is being practiced by us in the real life. Another number system that is being practiced in computer systems, and this number system is being called as a binary number system. So as its name indicates, bi, it will stand for 2. Therefore, there are only 2 basic numbers, and those numbers are 0 and 1. So in decimal we have a base of 10, in binary we have a base of 2. So there are only 2 basic numbers, 0 and 1. So after 0 and 1, we make the combination of 0 and 1, and therefore it is written as 10. So 10 in binary is different from 10 in decimal. In decimal we call it as a 10, but here we do not call it as a 10, we call it as a 10 only. Then it is 11, that is 100, then it is 101, then it is 110. So in this way we can make the combinations of the binary digits, and so that we can write infinite numbers. As in case of decimal, we can write the numbers positive, negative, whole and fractional. Similarly, the same thing is applied to the binary numbers also. We can write positive, negative and whole numbers and fractional numbers. Whenever we want to write positive number, we can make the use of plus sign or no sign. Whenever we want to write a negative number, we can make the use of minus sign. Also, it is possible that whenever a negative binary number, then that negative binary number can be represented by the sign bit also. For example, if I write a binary number 10, and if I want to indicate it is positive, I will write 0. If I want to indicate it is negative, then I will write 1. So this will indicate that this is a negative binary number and this is a positive binary number. So it is possible that you can make the use of the sign bit, or sometimes we can make the use of ones complement, twos complement method, and by using that method we can represent the negative binary numbers. Maybe in our later sessions we will discuss how to make the use of ones complement and twos complement method. Also, we can write the fractional binary number. Say for example, if I write a binary number 10.01, then you will find that this is a fractional binary number, and this 0 will have the weight 2 to the power 0, this 1 have the weight 2 to the power 1. So again, from the fractional point, when we go to the left hand side, the weight goes on increasing, and from the fractional point when we go to the right hand side, the weight goes on decreasing. This 0 will have the weight 2 to the power minus 1, this one has the weight 2 to the power minus 2. So weight of every binary bit is in the powers of 2. Always remember that in case of decimal number system, the weight is in the powers of 10. In case of binary number system, the weight is in the powers of 2. So these are the different examples. So whenever I want to write a binary number, then you can make the use of this 2 suffix, and that will indicate that this number is a binary number. Now let us go for the discussion of another number system, and this number system is being called as an octal number system. And octal number system, as its name indicate, that it has a base of 8, that there are 8 basic numbers from 0 to 7. So these are the basic numbers from 0 to 7, and after 7 what we will do, we will make the combination of basic numbers, and therefore we will write 10, 11, 12, and in this way we can write the infinite numbers. But observe that 10 in decimal is different from 10 in binary, it is different from 10 in octal. So in octal number system, we can write the positive number, negative number, whole number, and fractional numbers. Positive numbers can be indicated by plus sign, negative numbers can be indicated by minus sign. And whenever we write any fractional octal number, then we need to write a fractional point. Say for example, I write a number 12.67, where this 2 has a weight of 8 to the power 0, this 1 has a weight of 8 to the power 1. And when we go to the right hand side of the fractional point, then the weight goes on decreasing. This 6 has a weight of 8 to the power minus 1, and this 7 has a weight of 8 to the power minus 2. So in this way, you will find that there is a decrease in the weight to the right hand side, and there is an increase in the weight to the left hand side. And every weight is being represented in the powers of 2. So in decimal, the weight is in the powers of 10, in binary the weight is in the powers of 2, in octal the weight is in the powers of 8. And octal numbers are very important number system, because octal numbers you will find that they can be easily converted into binary. So whenever you have been given a large binary number, then that binary number can be represented easily in octal, and octal numbers can also be easily represented by the binary, and that is the reason this number system is used many times in the programming. So these are the different examples of how to write the octal numbers. So here we are writing the base 8, and the base 8 will indicate that this is an octal number. Another number system that is being used in the programming in computers, and this is being called as a hexadecimal number system. And as its name indicate, here we have a base of 16. That is, there are 16 basic symbols. From 0 to 9 means 10, and from A to F. So these are the 16 basic symbols, and therefore after F you will find that we will make the combination of basic numbers, and we can write 10, 11, 12. So in this way we can write 19, then 1A, 1B, 12, 1C, and in this way we can write the infinite numbers. So as you know that 10 in octal is again different from 10 in decimal, binary, and hexadecimal number system. So the numbers can be positive, negative. Positive numbers can be written by using plus sign, negative numbers can be written by using minus sign, fractional numbers can be written by using the decimal point. So here you will find that when I write this number, this 1 in this number will have a weight of 16 to the power 1, this A has a weight of 16 to the power 0, this 6 has a weight of 16 to the power 1. So the weight is in the powers of 16, and from the fractional point to the left hand side the weight goes on increasing, and from the fractional point to the right hand side the weight goes on decreasing in the hexadecimal number. So every digit will have a weight in the powers of 16. So we can, the biggest advantage of the hexadecimal number system is that we can easily convert it into binary, or whenever we have been given a large binary number, that can be easily converted into a small hexadecimal number. And that is the reason you will find that the hexadecimal number systems are very widely used in computer programming. So whenever we want to write any hexadecimal number, then that can be written by using the base 16. So base 16 will indicate that this is a hexadecimal number. So these are the different numbers in the different number system. The decimal 0 is same as binary 0 in octal and hexadecimal. 1 is same everywhere. 2, you will find that in binary it is represented as 10, while in octal and hexadecimal it remains the same. 3 is being represented as 11. Then 4 is being represented in binary as 100, while in octal and hexadecimal it will remain the same. So you will find that up to 9, you will find that the numbers are up to same in octal. After 7, we will have 10 in octal, and as far as up to 9 is concerned, the number in binary, the number in decimal and hexadecimal are same. And then you will find that there will be change in the hexadecimal number system, because we have the numbers such as A, B, C, D, E and F, and then for decimal 16 you will find that we can have a hexadecimal number 10. So every time we are incrementing the number by 1. So one can easily observe from this table that how the numbers are written in the different number system, how it is written in decimal, how it is written in binary, how it is written in octal, and how it can be written in the hexadecimal number system. As I said, decimal number system is very popular. Its base is 10, the symbols are from 0 to 9, and it is being used by us humans in our day-to-day life. Binary number system has a base of 2. It has only 2 basic symbols, 0 and 1. It is not used by us in regular life, but it can be used by computers, because our digital computers actually store the data in binary form only. Then we can make the use of octal number system, where the base is 8, where the symbols are from 0 to 7. It is not used by us, but you can make use it in the programs. Hexadecimal number system has a base of 16. It has the basic numbers from 0 to 9 and A to F. It is not used by us, but it can be used while writing the assembly language programs. So thank you friends for viewing the session. Hopefully you have understood what we mean by number system and what are the 4 different popular number systems that we actually use when we study computer science. Thank you all.